What if I told you that the rise and fall of ocean tides are not just random events? That they're controlled by an invisible force, one that has been shaping life on Earth for billions of years. Let's uncover the truth about the moon and how it secretly pulls the strings on Earth's tides. Stay tuned. Welcome back to Atomic Domain, where we explore the mysteries of science and the universe. If you're passionate about uncovering the secrets of space, science, and nature, you're in the right place. Make sure to hit that like button, subscribe, and ring the bell so you don't miss out on our deep dives into the wonders of the cosmos. The moon's role in Earth's tides isn't just a story of cosmic coincidence, it's the result of some incredible gravitational forces at play. But to understand how this happens, let's first look at what tides actually are. Tides are the periodic rise and fall of ocean water levels, primarily caused by the gravitational forces exerted by the moon and, to a lesser extent, the sun. These forces interact with Earth's oceans, causing water to move in predictable patterns. Every day, most coastal areas experience high tides and low tides. This is due to the moon's gravitational pull on Earth, creating bulges of water in the oceans, one facing the moon and one on the opposite side. This phenomenon, known as tidal bulges, is the core reason behind high and low tides. So, how exactly does the moon cause this effect? 1. Gravitational pull. The moon's gravity pulls on the Earth's oceans, causing a bulge on the side closest to the moon. This is the first high tide. 2. Inertia. On the opposite side of the Earth, there is another high tide. This happens because as the moon pulls on Earth, the water on the far side lacks the same gravitational force and is left behind, forming another bulge. 3. Low tides. The areas between the two bulges experience low tides, as the water is being pulled toward the high tide zones. This interplay of gravity and inertia creates a dynamic cycle of high and low tides that repeat every 24 hours, following the moon's orbit around the Earth. You might think the sun would have a bigger effect on the tides, given its size. However, while the moon's gravitational influence is stronger on Earth's oceans, the sun does still play a role. When the Earth, moon, and sun align during full moons or new moons, the sun's gravity works alongside the moon's to create spring tides, which are stronger tides. These occur because the combined gravitational pull of the moon and sun produces extreme high tides and low tides. On the other hand, when the sun and moon are at right angles to each other during the first and third quarters of the moon cycle, the tides are weaker, known as neap tides. Tides are more than just an interesting natural phenomenon, they affect everything from marine life to human activities. Here's how. Marine ecosystems. Many marine species rely on tidal patterns for feeding and reproduction. Tide pools, for example, are teeming with life, thanks to the regular ebb and flow of water. Coastal habitats. Tides help shape coastlines over time by eroding and depositing sediment, creating beaches, bays, and estuaries.
Human activity. Tides play a major role in navigation, fishing, and even the design of coastal infrastructure. Many harbors and ports rely on tidal patterns to operate efficiently. But the influence of tides goes even further than just marine life and human activity. Tides have played an essential role throughout human history, shaping the way civilizations developed and advanced. In ancient times, the rise and fall of tides were critical for navigation. Ancient sailors and traders relied on tidal patterns to plan their voyages, using the tides to their advantage to navigate coastal waters and reach distant lands. Without an understanding of tides, the great seafaring civilizations like the Phoenicians, Greeks, and Romans might not have been able to establish trade routes and expand their empires as they did. The tide mills of medieval Europe were another key development, where tidal power was harnessed to grind grain, a feat that showed how even in early history, humans found ways to use tides for their benefit. Similarly, the construction of harbors and ports throughout history, from ancient Mesopotamia to modern-day infrastructure, was closely tied to tidal patterns, ensuring ships could dock safely and efficiently. In modern times, tides continue to influence navigation, especially in shipping, fishing, and oil exploration. Today, tides are also studied for tidal energy, a renewable energy source that harnesses the gravitational pull of the moon to generate power. The ability to predict tides is now an essential aspect of technology that impacts industries and coastal communities worldwide. Did you know the moon is slowly drifting away from Earth? About 3.8 centimeters per year. This gradual change means that over millions of years, tides will continue to weaken and will eventually alter Earth's rotation. While this may sound alarming, it's a slow process and won't affect life on Earth for billions of years. Additionally, the moon stabilizes Earth's tilt, which helps regulate the planet's climate. Without the moon, Earth's tilt could vary wildly, leading to drastic climate shifts. The moon's influence on tides is so strong that, in some places, the difference between high and low tide can be up to 16 meters, about 52 feet. That's taller than a 5-story building. And there you have it, the fascinating dance between the moon and Earth, a cosmic interaction that shapes our planet in profound ways. From the way tides influence marine life to how the moon stabilizes our planet's climate and has shaped human history, this relationship is crucial to life as we know it. If you enjoyed this deep dive, make sure to like, comment, and subscribe for more content that uncovers the hidden forces shaping our world. Share this video with your friends so they can learn how the moon is more than just a bright nightlight in the sky. It's a cosmic force with a huge impact on Earth.